This video, we're going to start Chapter 10. Chapter 10 is interested in organic chemicals that are secondary byproducts. And so the first topic we're really not going to focus on, but it's really important for us to understand that hydrocarbons in Alberta are a large source of revenue and that there are a lot of jobs that depend on them. And those jobs aren't just mining or trucking, but there are lots of jobs that come from processing and making things from the organic chemicals that we get out of the ground. So we're going to kind of breeze past chapter 10, but it's really important for you to understand, or 10.1, but it's really important to understand that when we're considering this, that you understand that the jobs that are present in Alberta um, are really sort of the backbone of a lot of communities. And so Edmonton, most of the jobs will be connected to the fossil fuel industry in some way. As a teacher, tax base is contributing to paying my wage, so you can't divorce my job from the hydrocarbon industry as well. But a lot of small towns have processing plants, and the processing plants for the hydrocarbons are going to be one of the major employers in the neighborhood. And so as those um, plants thrive, the communities continue to do well, and if those plants shut down, it has a direct and major impact on the economy as well as the town stability and migration into and out of the city and into and out of towns. So it's a big deal in Alberta, and so chapter 10.1 in the textbook kind of tries to shine a light on that. We're going to really get more interested into the specifics about the organic molecules in chapter 10.2. And we're going to study now the organic halides addition and substitution reactions. So organic halides are molecules that have a halogen as a functional group. So it's our first time running into this term functional group. And functional group is something that is defining the behavior of the organic molecule. So an alkene or an alkyne, the double or triple bond change its behavior quite a bit. We could consider those a functional group. But in chapter 10, we're going to really emphasize some very specific functional groups. And the first one we study is organic halides. So organic halides can be slightly polar because what they've got is they've got a hydrocarbon attached to a halogen. So our general way of referencing this is my X is going to be any halogen and R is any carbon chain. So here, this is chloromethane, and you can see that there's a chlorine that's taken the place of one of the hydrogens. So this chlorine makes this chemical have very different chemical behavior. It reacts differently, it has a different melting point and boiling point, it affects the solubility because the chlorine is got an electronegativity that is bigger than hydrogen. So hydrogen is 2.2, and I think chlorine is about a 3.2 or 3.4 or something like that. The electrons are pulled more towards the chlorine, and so this bond length will be different, and the chemical reacts differently. So often organic halides are going to have a slightly different boiling point. Obviously, the halogen has more protons and electrons, so it has more London dispersion force for chloromethane than methane would have. But it also is going to be slightly polar, and that's because it's got one side of it that's got a different electronegativity than the rest. Organic halides are less reactive than organic molecules, and that's got to do with the bond that's here. This bond is harder to break. There's a stronger attraction between the carbon and the chlorine than there would be between the carbon and the hydrogen. And so it's actually just a little harder to burn organic halides. Organic halides can be very slightly soluble in water if they're polar. They are not all polar. So organic halides are going to get named exactly like we've named branched chain alkanes. So essentially, the branches are going to be, instead of having like methyls, we're going to have bromos, chloros, fluoros, iodos. So when I'm naming this one, I've got this is a carbon, this is a carbon, this is a carbon, and this is a carbon. So I know that this is a butane. And I've got bromine and a chlorine. So I can go 1, 2, 3, 4, or I could go 1, 2, 3, 4. And so I'm going to get bromos and chloros. B comes before C, so I'm going to count with to get the lower numbers on my bromine than I'm going to have for my chlorine. So 1, 2, 3, 4. So I'm going to get a 2 bromo, 3 chloro, butane. And over here, it's obvious I'm going to start counting from the left-hand sides to get the lower numbers. 1, 2, 3, 4, 5, 6. So we're going to have a hexane, and I'm going to have a bromine on the second and the third. So it's going to be a 2, 3 dibromo hexane. And over here, if I wanted to draw it, I've got an ethane. So I'm going to have 2 carbons, and I'm going to have 1, 1, 1. So on the first carbon, I'm going to have 3 bromines. And on the second carbon, I have 1 bromine. So I've got 1, 1, 1, 2 tetrabromoethane. So this is going to still have hydrogens here. I guess if I was going to draw this, this would be like Br3C, C, H2Br. This would be probably the way I would show it because it's the most logical way of showing it, but you know, you get the idea. So this is going to be a hexane, so I'm going to have 6 carbons. And I've got on the second carbon, I've got a chlorine, and on the third carbon, I've got a methyl. So this is a branched alkane with an alkyl halide. So now I've got C6, so I've got H3, this has got 3 bonds, so it gets 1 H, this has got 3 bonds, so it gets 1 H, this has 2 bonds, so it's 2 H's, 2 bonds, 2 H's, and then this is going to get 3 hydrogens. So now let's say I was trying to figure out what the molecular formula was for these things. So butane would be C4H10, because that'd be, so that's for my butane, because it'd be CnH2n plus 2, because it's an alkane. But I have a bromine and a chlorine here. So that took the spot of 2 of the hydrogens. So it'd be C4H8 BrCl. And over here, I'd have 6. So I'm going to go C6H, it'd be 14, but I have 2 bromines. So I'm going to have this be 12 Br2. Right? And over here, I had an ethane, so it'd be C2H6, but I have 4 of those being hydrogens. So, or 4 of those being bromines, so I'm only going to have 2 hydrogens left. And over here, I've got 1, 2, 3, 4, 5, 6 in my hexane and a methyl, so it's going to be C7. C7 would be H16, but I've lost 1 of the hydrogens, so it's going to be 15Cl. Okay, so practice these diagrams. I'll caution you that for example B here and for F, I would not ask you those on a test, and I would not ask you this one on a test. You can easily do them, but I'm not supposed to mix and match functional groups. So I won't have alkenes with halogens. I won't have alkynes with halogens. I'd have alkenes, or I would have alkyl halides. Okay, so just to be a little bit careful, I'm a little bit more restricted than the textbook for asking questions. Give these questions a try, and we'll pick up with another video for alkyl halides.